Good afternoon, welcome to Build, and thank you for coming to this session on Azure Service Fabric. Great to have you here. My name is Mark Fussell. I'm a program manager that works on the Azure Service Fabric team.
And I'm Václav Turček. I'm also a program manager on the same team.
And we're going to take you on a journey today. We're going to take you on a journey of how you modernize some of the applications, how you may have started with executables or have something that's running today. And through that journey, we're going to talk a lot about containers and other things to help you on that journey. And particularly, we want to take away from this, how is it that Service Fabric helps you build these distributed apps? And on this journey, we'll intersperse this with a number of different things about the future-looking side of Service Fabric. This is an intro talk, so we're expecting you have some familiarity with Service Fabric today. If you're totally new to this, there's going to be a lot of stuff inside here that builds on some of the concepts we have today. But it's a journey, and we're going to take you from the beginning, and you'll see a lot of stuff that we do. So to recap, Service Fabric, it's a distributed systems platform. We use it to build a lot of services in Microsoft. It encompasses everything from a developer side of things all the way to the ops side of things. This time last year, we released Service Fabric as a service inside Azure. So you can go and host a cluster of machines, and inside Azure there, you can run it on Windows. And then we also, at the same time, released, of course, you can run it on your single dev box as well. Back at Ignite, we released our on-premise version, so you can deploy Service Fabric inside your own data centers, and that's had a huge adoption with people. It's been extremely successful because you can run Service Fabric just by taking a set of machines, hook them together with a network, run a single PowerShell command, and you have a cluster running up in under a minute on 5 machines. At Ignite last year, we also released our Linux preview inside Azure. You can go into Azure. You can create, inside our portal, you can create a cluster there with the Linux Ubuntu machines, deploy that, and inside that, of course, we have programming models based around Java and your Jenkins for the CI/CD pipeline, and a slew of stuff effectively allowing you to have a full Java experience. And as we get towards the end of this year, we're super excited that we're on the home stretch for our Linux offering. You'll see our Linux offering GA this year. We've only got 6 months left now, so we're on the final ramp for that. And you'll also see Service Fabric become part of Azure Stack. So as well as the standalone experience where you just take a set of machines and deploy it, actually, if you come down to our booth, you'll see our little mini stack that's running there, if you've seen that. You'll also have an experience of Azure Stack as an appliance that you can have Service Fabric in. So we love to think that Service Fabric is available everywhere and on any OS, as long as it's Windows or Linux. And you can deploy those into a number of different environments. And so you can progressively start inside your own data center, build and take advantage of things that are running there, and move to Azure, and making it your choice of Windows or Linux, and in different environments. And we don't pretend that there are other people who've taken Service Fabric and run it in other clouds as well. And we have other customers who run Service Fabric in production in other clouds. You can do that. It runs best on Azure, but you can do it all. So, it's a very flexible offering around all these things. When you look at the spectrum of what you can do in terms of Service Fabric, as well as being a distributed systems platform which contains orchestrators and the fact that it can deploy a set of processes on machines, we provide a rich set of productive programming models. And we provide a reliable services programming model that helps you build instances of stateless and stateful services. We layer on top of that our hugely popular actor model that allows you to create these individual little objects that have their state and code encapsulated, and you can create millions of those across your cluster. And then we're great advocates. We love ASP.NET Core and the .NET Core runtime and hosting all those on top of us. But of course, on this journey, often you don't necessarily start with that. Often you start with some existing code. And so you can bring executables and run that on Service Fabric. And now increasingly we've embraced and brought containers to Service Fabric, so you can run containers there as a first class. And that's what we're going to spend a lot of our time talking about today, and then show how you augment that with our programming models to take you on this journey of building a microservices-based application. Now, hopefully, as many of you know, you heard in Scott Guthrie's keynote, we build our services on top of Service Fabric. This thing's no longer called DocDB. It's called Cosmos DB, which is far more flashy as a name. But nevertheless, Service Fabric is the underlying infrastructure on which these services are built. And huge numbers, millions of cores are run on Service Fabric. We say 30% of all Azure's compute is actually running on Service Fabric in some form with all our hosted services. So we truly think about this thing as being designed for mission-critical services We bet our business on it, we bet our services on it, and we totally treat this in the same category that you can build mission-critical Tier 1 services on this platform, and that's exactly what it's designed for. So we're unique, we believe, amongst the cloud providers to give you the same code and the same platform that we've just rolled out across our services a few days before, in many cases, or weeks before in testing, and then give it to you on a regular cadence basis. So it's a very interesting platform in the way we look at it all. We've had a slew of customers, huge numbers since we released the GA last year. This is a few of them. Who've gone into production or close into production, and we've been working very closely with them all, and we love nothing more to engage with you as a customer, either down at the booth or send us direct with email. We're more than happy to spend time with you and to make you successful with this platform. It's one of our joys that we effectively do. So let's take you on this journey about what you're going to do and what you can do with Service Fabric. And how is it we think about migrating traditional applications and code you have today. So typically, you might have some code today, wrapped up in some package as an executable of some form. And the first step we talk about is how you can move that to Service Fabric and just use it for a distributed systems platform in order to deployment and management of that pieces of code. You can deploy executables across this cluster of machines, you can do upgrades, you can do health monitoring around them all, and you get all the benefits of a platform effectively where you can manage and deploy that code, whatever that piece of code is. We have customers who do JVMs and executables and Node.js applications, and they just bundle them all up and then host them on Service Fabric and get them all running as their first step. Of course, increasingly as well now, this is becoming containerized applications. And then after that, we see people go, now I've got my code running, I now want to take advantage of adding new little pieces around all of this. So typically using Service Fabric programming models, but you don't have to. You can deploy other services around all of this, where those services are independently scalable, versionable, and deployable as individual microservices. You can choose to tackle that big monolith and decide, because of deployment agility or because of scale out, you tease a piece of that out, and finally you might end up in this fully microservices world where you end up with a full application that's distributed with numerous little bits of code that are independent, versionable, scalable. But the point is you can stop at any point in this journey. It doesn't matter. You can take advantage of the platform. We're not telling you to go all the way to the right or to the left. This is just a thing that you choose depending on your business need. Now, last time we spent a lot of time on talking about microservices and the platform we build it all. We're going to spend now a bit of time to go back to the beginning of the journey to talk about Service Fabric and how it works as a container orchestrator. So I'm sure many of you are aware of containers and what they do. It's an image-based format, Docker being one of the most popular types of things. It's built into Windows Server, and in Windows Server you can take a base image and layer a number of different images on top of that, push that into some registry, either Azure Container Registry or Docker Hub, and pull down those images and deploy them all, and you get a lot of the benefits of a self-contained package with all its dependencies within inside this all that you can deploy and you can provide resource constraints to. Wonderful technology if it fits your particular scenario. And so this is a classic way we think about containers. Now, Service Fabric has been a container orchestrator for many, many years, and it's been highly optimized over all our large workloads. If you think about how we run millions of Azure databases, some of them are ginormous, some of them are small. We've got to think about all the packing density around these things. We have to highly optimize the efficiency of these clusters because it costs us money. We've got to make sure we can get the best we can out of a several hundred machine cluster when we run Azure databases. And we've done that a lot with processes over the years, and we put other constraints around them all. But we're super excited that Service Fabric now is GA'd as a Windows container orchestrator. And you can take this into production and orchestrate containers as well as processes inside your applications that you deploy. And that was the announcement that Scott Guthrie did in the keynote, and we've followed it up a lot more with other announcements around here. So this is a great achievement that we're looking forward to bringing all your Windows workloads. And as we look towards the rest of the year, you'll be able to do full orchestration as well on top of Linux and our other platforms. In fact, it's worth noting that every time we build features, every time we talk about a feature, that feature is in Windows and Linux. We don't differentiate between those in any way. So if you go and take our Linux offering right now, it's a container orchestrator, and the same we're about to talk about today. Okay, let's just briefly go through some of the capabilities of what we mean by you've now got a container orchestrator. What does it do for me? What have we given them? So Clearly, the most obvious one is it'll pull down container images, deploy them across a set of machines, and orchestrate them and activate them. And it'll do the image-based deployment, and it'll also do the authentication against the registry wherever you have your images. You can also provide in a set of environment variables, and it's a very common way of configuring the container in terms of some settings that you may have. The next thing it does, we can hook up volume drivers. We've integrated volume driver support. In the Linux world, there's quite a lot of volume drivers there already for different external storage or storage options that you can hook up to. So that's the predominant thing. You'll see volume drivers coming out from us. We've got networking capabilities. The networking that's built into the containers at the moment is a bridge-type network where it maps the container ports to the underlying host OS ports. So you do that container-to-port mapping around them all. And once you launch your container inside there and do that port mapping, effectively, you can call down onto container host ports through to the actual container inside there. When we launch the container, we allow you to take that endpoints and register them with our naming service for discovery amounts to more. And then because the naming service is our central resolver for all the names inside the service, in order to make your lives easier with existing applications, we put it included as part of the Service Fabric offering in this release, a DNS service now. So if you want to use DNS protocol for resolving the location between your containers, and then that will call down onto the underlying naming service to be able to do the resolution, it makes it considerably easier to effectively do cross-container calls, particularly for stateless apps. Of course, you get resource governance on those containers. We apply resource governance policies for CPU and for memory and the things that come out of the box really with Windows containers. But we've also gone and done it where we provide those resource constraints on processes as well. So if you're still in that, want to just launch a set of processes and I don't want to go through the whole build process and things with a container, we've allowed you to do that as well, which is a unique offering because it allows you to progressively just do it to existing workloads that might be running. We work with Hyper-V in terms of Hyper-V isolation mode. Corey Sanders yesterday announced a couple of new SKUs that are coming. VM types that are coming to Azure, which are DV3 series and EV3 series, which have Hyper-V isolation turned on. So if you want to have a Hyper-V isolation mode on your containers when they run inside Azure, you can pick those SKUs. Outside of that, of course, you can just take your on-premise hardware, turn on Hyper-V isolation, and run there as fully isolated containers that are running there with their own kernel. And then finally, one of the interesting things that we've added in a special release that we've done as part of a preview release is that we've added support for Docker Compose. And what this means is that we first class understand what Docker Compose looks like, the model for it as a deploy model, and we'll understand that and use that as a way of launching a set of containers that you can pull down. And effectively, you can take existing lift and shift applications because you run them on Docker Enterprise or some other orchestrator that has Compose built in, and use those to launch inside Service Fabric. So let's talk about what we're going to do.
This is
with
the start
app.
of our journey.
Yes.
Okay, good. So here's where we start. So you have some, like Mark mentioned, you have some application that you have today. It's not built on Service Fabric. It's not meant for Service Fabric, but you want to get the benefits of the platform. You want to run it on Service Fabric for all the benefits of failover, upgrades, that sort of thing. So we start with our existing application, and what we do is we take this, like Mark was saying, we put this into Docker Compose. So this is that Docker Compose capability we added just recently. In this case, this is an example application that we're going to actually show you today, and we're going to kind of walk through it, where we've taken a legacy, or we'll say a classic ASP.NET application, which runs on IIS, could be on web forms, could be on classic MVC. The point is it's not running ASP.NET Core, so it's not self-hostable. And if you've used Service Fabric in the past, you've probably heard us say something like, sorry, you can't use IIS. Because IIS is an EXE orchestrator, we're an EXE orchestrator, they don't really work well together. So the answer to that is you plop those things into containers, and now it's easier than ever to just take that and host it on Service Fabric by using Docker Compose. Or perhaps you have a Docker Compose application already. Now, the way this particular application works that we're going to show you is there's a client application, there's a client, it's just a single page application. Now, when this thing makes a connection out to our front-end service, what we've added in Service Fabric is this DNS service. So the way these two back-end services communicate now is through this DNS. And the DNS service runs as a service in Service Fabric, and it works like any way that DNS does, right? So it'll give you an IP address when you try to resolve a host name, and then you can then connect directly to that backend service. So I think Mark's going to show us that.
Let's do demo
show us that
time.
in action.
So
let's just take a look.
switch over.
That's enough talk. Let's see it.
Yes.
Here you go.
Okay. Ooh. Okay, here
That's
we have.
you.
Here's our application. So as you see here on the right, we have our two legacy applications. We have our web app and we have our data app here. And all we did is when we created these apps, we went in and did add Docker Compose to all of these. It created a Docker Compose file for these legacy applications. And as you can see inside here, inside the controllers, if you look at this web app inside here, I just have this TCP controller inside here. And all it simply does is it just uses a DNS call to my other service. So it just does the call here to, say, to my enterprise data app here on a particular port. And my other controller here just effectively does some data processing inside all of this. So nothing changed about my application, just doing a straight HTTP call. Of course, my Docker Compose for this particular app that I have consists of these two services, my legacy enterprise data app and my legacy enterprise web app. You know, these two things are the DNS names that get resolved, and of course I can tell where to pull the image down from. This is up on my Docker Hub, and to open up some ports. So, I haven't touched anything about this application. There's nothing in here particularly about Service Fabric just yet. But what I'm able to do is I'm able to go and look in this cluster here that I have. This is a Service Fabric cluster I'm hooked up to. You see now that inside here I have a DNS service running, which can do all that name resolution for me. I've got no app deployed, so how is it I can deploy my app? So I can now go back and take a Docker command, Service Fabric command here called new Service Fabric Compose application. And I can simply give it the name of the application I want to launch and say, here's that compose file that you just pulled down and you already had running. So let's take this thing here, let's run this. And what this will do is it will deploy that application instance inside the cluster here. You see it's creating here. It'll create an instance of the legacy app, and it pulls down two instances of the front-end service and the back-end service here. These are the running here, and for each of these, it's launched a single instance inside here. So here we are, we have a single instance of this web app and a single instance of this legacy data app. Now I can go in here actually, I can do, unless there's a new action we added in here, I can do scale service. I can do -1 inside here now, I can hit scale service. And what that will do is it will scale out this particular service across these set of front-end machines here now. You'll see that get deployed there in a moment as it scales out across there. And the -1 indicates, for you who don't know, I deployed these across all the machines inside my cluster. So now it's deployed a containerized image across each one of those. It's downloading it and deploying it onto each of those particular machines. So now I've got my web front end running on all my machines and a single back end at the back here now. So I've just deployed my app. I can go into the site here. I can do refresh on the endpoint here. This will hit the Azure Load Balancer. It'll hit one of those endpoints. It'll start accessing the container on there. It'll load up the container for the first time as it comes through. And if we've hit one of the sites that has got to yet warm up with this container, we'll have it launched in a moment inside here. There we go. There's our app running from our web front end. Now what I can do is I can generate a report here. So I can do new report. This is just a little UI that we have, report. And I can say start and call onto that backend service here. And there it is, that's calling onto the backend service through the DNS resolution between those two services. No change of code, nothing to do with Service Fabric, just composed, deployed it into the side there, running my legacy IIS applications. So how'd you get rid of it? You get rid of it with a single PowerShell command. Remove Service Fabric PowerShell. And so I can just kill this thing here. And if we switch back here, and, ooh, wrong one, hang on, go back here, and it's disappeared already. Well, there you go, so it's no longer here. So, that's as straightforward it is to deploy Compose as an application inside of these, and, it makes it extremely simple for you to take those legacy apps. That's part one of your journey. Let's switch back.
Switch you back. Here you go.
What are we up to next? So a customer who effectively has Service Fabric running in production today, if you go to alaska.com and you buy a ticket for Alaska Airlines, they've stood up a Service Fabric cluster. We've been working with them for a while now. They've been having this running in production for several months. We gave them early preview bits that we stood by in terms of the guarantees around it all. And they launched and run alaska.com as a website. It's a critical business to Alaska in terms of how all their revenue comes through all that. It's hosted on a Service Fabric cluster. They they simply took their IIS applications, hosted them inside Docker containers, and did exactly what I just did to deploy that across a cluster of machines. And now they can just scale that up and scale it down. And for them, what was exciting for them is that they have a lot of Black Friday events and times where they want to have big demand. They can scale the cluster up, and then when they have less demand, they scale it down and save themselves a bit of money. So it's a great example of one of the many customers now that are starting to move these IIS workloads and host them on Service Fabric. And we're very excited that they're able to do this. And we're hoping in the next few weeks, or actually even less than a week, we'll publish a technical article about how they did all of that. As we look towards the future, what are we going to do with containers? And this is rapidly coming. We're talking about, like, in the next release, we release every 8 weeks. We just like go bang, 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 new releases. Actually, every 4 weeks release features and then bug updates every 4 weeks. But in the next one, we're going to do a huge amount with networks. First, we're going to allow you to specify an isolated network. So when you deploy that application, you can set an isolated network within all the services that run inside your application. So only those services, only those containers or those services can see each other within inside that application deployment. So it allows you to do a fully isolated multi-tenant environment where any application can only see the other services within inside it all. Super cool, because now you can truly run all those independent workloads without them seeing DNS calls to other ones. So this is this is cool. This is a bit like overlay network, if you know this. But we're going to go further than that. The other thing that we're going to do is that we allow you to host all the containers inside your cluster. And we'll have this networking mode that says, take your cluster of 20 machines or whatever it is, and all the containers that get launched inside that will have fixed IP addresses. And you'll treat them all on a single IP network. You'll think of them as like VMs now, but they're just containers. They're all addressable with a fixed IP address. You can include them in part of any of the networking technologies inside Azure, like network security groups or load balancers. You'll be able to call for them from the outside world as well. And if the containers fail over, when they start up on another machine, they'll retain that fixed IP address. So now you'll have this world of effectively containers that can have visible across all the cluster of machines with fixed IP addresses, as if you are completely abstracted away from the underlying host itself and you're just dealing with containers inside there. A super cool feature capability is how you're going to do networking capability inside here. These are in development now, and you'll see them come very soon. We actually even tried to get them in for this last release, but it just was not possible. But they're actively in development, and we think this will, the bridge network, for all of its host network mapping wonders, is a bit awkward to use. These are the ones that effectively will be the ones that will be the predominant use of networking inside there for containers. But we're going to do more. We're going to make sure that when you deploy a cluster inside Azure, we're going to configure those machines with the right resource governance metrics inside there, so that already in advance we know that this machine has the real metrics for the number of CPUs or number of memory, so it gets pre-calculated for you. So when you say, oh, my container just needs 1 core, it's already pre-configured with the number of cores it knows about for some of the VMs. We're going to make sure that the Service Fabric programming models, reliable actors and reliable containers, run inside containers, and you can deploy them inside here. We're going to make sure that we have deeper integration with VS tooling. It's a little bit awkward right now because we have a Docker Compose project outside of Service Fabric. We're going to integrate and pull those together. And of course, we'll always make sure that Service Fabric Explorer has more container capabilities. And then we're going to do exciting things as well for stateful compute. We are stateful compute lovers. And we know that a lot of people have difficulty with state management. And so one thing we're going to build and have building is a volume driver that you can connect up to your container, where the volume driver, there's going to be a volume driver for Azure, by the way, to externalize storage, but Service Fabric is a storage technology. It replicates all its state. So we can put a volume driver effectively onto your container to replicate the state across the local machines and make them highly available for you. And it's incredibly fast, and the failover times of a container will be the failover times of a container will be the fact that it moves over to another machine and then remounts the volume and recovers all the data from there. So let me show you a little demo of what this pre-prototype looks like. Press that 8. Go. So here I have a cluster. And this is an early prototype, by the way, so please don't judge it on perf just yet. But it's a cluster of machines, and inside here I have a containerized application. And all I've had to do inside my containerized application that's running, and there's a single instance of it running here, is I've put this volume driver statement inside here. I've just said, this container It's going to write everything to its C drive or C:/ the data drive, and when it does, it's going to write it all out to disk, and you're going to deal with all the replication of all the state. So as a developer, I just deal with file I/O, but the volume driver deals with all the hard problems of replicating that state and making sure it gets recovered. This actual little app is, I've got a little web endpoint pointing onto this container which shows a counter that's counting away, that's connected to this thing. In fact, I can even reset the counter here so it starts from the beginning. So what I'm going to do, this is running on node number 2 here. I can actually just go over and I'm going to restart node number 2 in the classic way that we do all our failover in Service Fabric, because we love failover. I tell you what, this...
We don't like clicking on things, though.
No, I don't like clicking on anything. Here we go. There we go. I just found that this is the easiest way of doing this thing. So we're going to fail over node 2. Let's watch this counter over here. So we disable node number 2 on this machine. As it shuts down node number 2, you'll see that the container has to now be forced to fail over. It'll fail over from 2 to some other node it'll pick inside here. It'll probably pick 4 or 3 or 3. And then when it recovers, it'll start up the container again. Watch the counter on the right here as it keeps counting, and then it recovers and starts that container. And when it recovers, because we're going to do some more perf optimizations, there's my counter that's recovered, and I've kept all my state inside my volume container across a volume drive built on Service Fabric storage. This is pretty cool stuff. Yeah. This is cool stuff. And this is going to be low latency, super fast, and you'll be able to use the Azure one as well, but you can take advantage of both. And so now that's state management inside containers for you. You're going to have a fun time with this one. Let's switch back to those slides. I think you're up next.
Oh, I knew I was here for more than just clicking the buttons. Okay, good. Okay, so continuing on our journey now. So we showed you how to take an existing application, put it on Service Fabric. Now we're going to do the step 3, which is we still don't want to change this main application, but we want to add a couple new modern services to it, kind of enhance the functionality. So we're adding new functionality, but we're going to do it in services on Service Fabric. So we take our Docker Compose application, and basically what we're going to do is we're going to turn this into a Service Fabric application. So we're really just moving these over, still not touching those, but then we're going to add additional services built on our Reliable Services SDK and using ASP.NET Core as the application framework on top of that. So let's talk a little bit about how ASP.NET Core actually works on Service Fabric. Traditionally with ASP.NET Core, the web host part is something that you spin up in your process. And this is actually the reason that it works so well on Service Fabric, is because it's all self-hosted. So in your program main, you spin up the ASP.NET Core web host, and that starts up your web server and your application MVC and all that stuff. So this is what we call self-hosting, as opposed to, say, an IIS, where IIS hosts the process for you, loads up a bunch of DLLs, but then manages it, right? So your server's running in your own process here. Now, in Service Fabric, we still do something very similar, but what we really want to do is we want to host this in our Reliable Services, because we have a slightly different life cycle than just an ordinary process. So ASP.NET expects you to follow the process life cycle. The process spins up, the web application comes up, the process goes down, the web application goes down. In our world, the host process can stay up for a longer period of time, and we will actually activate multiple service instances in that process, or you can do exclusive mode, either way. But the point is that you're going to get multiple things coming up in that process over and over and over again. So you have to get ASP.NET Core to kind of participate in that life cycle. And so we have this plugin model for opening up all kinds of network communication. And again, this is, you can use whatever you want here, but we have this interface called iCommunication Listener, which you maybe seen before. This is where you actually bootstrap ASP.NET Core. So when this starts up, then you start the ASP.NET Core web host, and you can see from here, it's actually fairly familiar at this point. So we'll switch over to Visual Studio real quick, and you'll be able to see what that looks like here. So, okay, so on the screen I have, this is just a traditional Service Fabric application. And inside I have 2 ASP.NET Core services. So if I expand one of these, what you'll see, this is actually just the ASP.NET Core project type. This is the regular ASP.NET Core Visual Studio project type with dependencies, controllers, root if I had one. All that stuff is the same. The real difference, as I talked about, is in the program entry point here. Instead of bootstrapping ASP.NET Core, we bootstrap the service fabric, reliable services with the runtime. And then that loads up your service instance in here. And then this is that iCommunication Listener plugin interface. But at this point, we essentially kick control back to you and say, all right, now you can set up your web host just like you do with ASP.NET Core normally. So you still have that full level of control. It's really just getting this piece in here to participate in our service lifecycle. So that's all that is. And we support Kestrel, we support Web Listener. We actually have this Service Fabric integration, which does a little bit of work to ensure that there is basically unique mapping of services so that clients don't actually connect to the wrong service because we're in a shared hosting environment. So that handles that stuff for you. Okay, so I've got 2 of these services. Now, the last thing we have to do is we just need to add our old legacy services in here. So this is something that's built into Visual Studio. We can just say, go and add a new service like we normally do, and we have a container template. The container template actually just takes an image name. So if I switch over to here, I can grab one of Mark's container images that he has up on Docker Hub and just say, this is the image that I want to use, and then I just give it I give a service name down here, so we'll call it legacy web service, like so. Okay. So what this does is this doesn't actually create a service project because there is no service project. We don't need one. There's no code. It's just the package, the service package itself, which contains our service manifest. This is just the definition of how the service should run. And you can see in here where you would normally have an exe host. Instead, we have a container host. And inside the container host, we specify the location and the version of the image, the container image that we want to pull down. Now, this gets pulled down at runtime. You don't actually see it on your machine. Once you go and deploy this, then when we activate it, we go up to Docker Hub, we grab the container image, pull it down, and activate it. So that's how that works. That's why you don't actually have a project here. So that's all that is, and that's really all it takes. If I want to add a legacy application or an existing application, whatever it is, to a Service Fabric, that's it right there. So there's a little additional configuration that you can do for port mapping. I'm not going to do that today because I know you guys didn't come here to watch me edit XML. So what I'll do instead is I'll just add that second one that Mark has, and that's just for completeness here. So I'll take number 2, and we'll plop that in here, call that our legacy data service. There you go. And that's it. Now we have our 2 legacy applications still talking to each other over DNS, but we've added 2 additional ASP.NET Core services as supplementary services. They expose some functionality over Web API, just like you're used to. And before we run that, I'm going to switch back over and talk a little bit more about how this actually works. So the question then is, what do you do? How do you expose that new functionality to your application? I've added these services, but how do I actually modify the app to expose that? So there's a couple things you can do. The kind of traditional way to do this is your client application will go through the Azure Load Balancer, as it normally does, to the backend application. And at this point, it's always going to reach your legacy service. Now, how do you expose that new functionality? One thing you can always do is you can just go and talk directly to that new service. But the question is how? Because you have to go and resolve this service. This isn't using DNS. This is a stateful service. It's a little more complicated. So we have this thing in Service Fabric called a reverse proxy that you may have used in the past. This knows how to forward requests on to a new service. And that way, your legacy service, your existing service, can consume that new functionality that way. So this is an example of a kind of a gateway pattern that we call, which is where you use a stateless service as a gateway. Now, the reason you do this, if you look at this from an actual deployment point of view, the legacy application that you've deployed is a stateless service. It runs on every node, and this is important because the Azure Load Balancer is a level 4. It's a layer 4 load balancer. It doesn't know anything about Service Fabric. It doesn't know anything about services. All it knows about is IP addresses and ports. So when requests come in, it just sprays it across all your nodes, and there better be a service there listening, otherwise you're going to see timeouts. So when the requests reach this front-end service, they end up having to go through this reverse proxy so that the reverse proxy can route them to the right place. Now, this is a very traditional thing. We see this a lot, and everybody has to do this today because there's no other way to expose that backend functionality directly out to your clients. You always need something in the middle to do this work. Now, we got kind of tired of having to do this all the time. Our customers got kind of tired of having to write these gateways again and again and again. Okay. So announcing today what we're introducing is Service Fabric with API management integration. You can now use API management to route calls directly to your backend services. We built this in as a custom backend in API management. You can do service discovery and routing in your API management policies. You can do partition resolution back there, so you can route calls to direct partition. You can do replica selection. You can even select which replica you want to route to. And of course, we have resolve and retry policies that allow you to kind of make your endpoints a little more available for your users. So this is something we're working on now. It'll be available to you in probably about a month's time. It's not out in production yet, but it's coming soon. So here's how this works. Service discovery and routing. On your client end, if you make a request to something like, you can set up an operation in API management, something like API users with an ID. And then in API management, you can set up a policy where you take that ID value and you can add that anywhere you want into a service name. And this allows API management to actually route calls to a specific service instance. You may have thousands of service instances running in the backend. This allows API management to intelligently route requests all the way to the backend services. Same thing with partition resolution. When a request comes in, again, for that same URI, you can write custom functions where you can compute partition keys based on that ID and then route that again to the correct partition of a specific service. So these are all policies that are built in. So if we go back and look at our kind of overall architecture diagram, the way it'll work now is that the API calls that come from the client, instead of going directly to that stateless service, they're going to go through API management, and that's going to do the routing for you. Okay, so how does this work? If we look at our deployment again, same thing as we saw before, our stateless service on a stateful backend. The way this works is when a request comes into API management is now aware of Service Fabric's naming service, and so it does the lookup, it does the resolution, it does the lookup, and then it can intelligently route that call to the right place. And in order to enable this, we have actually developed a new client library that's based entirely on our HTTP protocol. This is something that we'll be releasing fairly soon, just as a set of standalone NuGet packages. So you can do API, or you can do Service Fabric management operations without having to install the entire runtime and the entire SDK on the machines, which is great for your build systems. It's great for API management, and it's standalone and very lightweight. So that's also coming out fairly soon. And so that's how that all works. Now, missed one thing here. Yes. The VNet. The VNet's important. These two things live in the same VNet. That's how they see each other. This is something API management has been able to do for a while, so we basically just took advantage of this and said, hey, if you deploy these in the same VNet, why not let them talk to each other? And that's how that works. Okay, so let's take a look at our legacy application again now. So here's what we can do. So we have our web service, we have our data service in containers. We don't need to touch these, we don't need to change these. They can still talk to each other over DNS the way they did before. For the existing functionality, when you load up your UI, you go through the load balancer hits your web service, loads up the web page. Great. Now our news services, this is where it gets cool. So we introduced this new service with ASP.NET Core. It exposes web APIs that will actually dynamically create new services to do processing jobs. So when you hit one of those APIs, it's going to go and create new Service Fabric services dynamically, and each one of those will be doing some processing work. Now here's the cool thing. Since those services are created dynamically, they are all named with the kind of the name of the processing job you're doing. So API management does this routing very intelligently. So when API calls come in through our single page application through JavaScript, they will hit API management, and that's going to route them to the right place. And the really cool one is down the very last one you see there, API reports name status. That name is being translated into a Service Fabric service name so that it goes to the right one and then gets a result from that. So I'll show you how that works real quick here in a live demo, which we'll see. Okay. So I got this running. Here's what it ends up looking like in the Azure portal. You can see this is my deployment here. I have API management, here's my Service Fabric cluster, and here's API management. I have them in the same resource group, but more importantly, they're running in the same VNet. They each get a separate subnet so they can run side by side, and they each get their own NSG, their own network security group, but they can still talk to each other. So that's how the deployment looks. Now if we go check out our application again, and I was sneaky. I went and created an instance of this while Mark was talking, so you guys didn't have to wait for it to deploy. So here's what it looks like now. So we did have to make a UI update, obviously, if you want to expose some new functionality. You're probably going to need a new UI for it. So now, instead of just creating TPS reports this way, which still should work, this is still going through DNS, and so this functionality should still work. But the really cool part here is, if I go down to here and I say, I want my report here, and I'm going to say, now do it for me. So this is going through API management. You can see this URL right here. There it is. Go back to Service Fabric Explorer. That actually just created a brand new service in Service Fabric, and that request was routed through API management. Here it is. There is this post request. This is my API management endpoint here, and I sent a post request, and I said, Here's the report name. I extracted that, and I created a new service using that name, and that now just got spun up. So I can create as many of those as I want. This is a very typical use case we see for job processing. If I want to do job processing, I dynamically spin up a new Service Fabric service, let it do its work. In this case, I use reliable collections to checkpoint along the way, so if it dies at some point, it fails over, I haven't lost any of my progress. That's essentially what it's doing. Now, so I can create as many as I want. If I click Get Status here, this is actually just showing the service itself. If I click Get Status, that's going and talking to this service directly through API management, and here's that request in the back end here. I just did a get. Here's that name of the report that got routed to that service. Now, I don't actually want to go to it. And then it came back. So that's all going through API management. No stateless gateways. I didn't have to write any routing. I didn't have to write anything like that. API management handles all that stuff for me. So that's how that works.
That is fabulous, yeah. We're pretty obsessed with gateways, aren't we, really?
Well, we had a lot of gateways.
We like to make sure that we work pretty well with those things.
Yeah, I mean, this is a very common thing, and there's a lot of options to how you write gateways into your applications to get to the back end. And the most common one, of course, is you have to write a stateless web service yourself, but it's work. It's work you have to do. It's a lot of code you have to write. And so API management now is the other option. Of course, there are a couple more of these, like IoT Hub and Event Hub. These also work as gateways into your application. These are a little bit different because instead of taking requests in, you're actually listening and pulling out. But those are other examples of gateways. So,
yeah.
Okay, Wolters Kluwer. This is a customer of ours. A lot of the concepts that we've been talking about, they actually are doing this in practice today. Dynamic service creation for job processing, that's something they do, and modernizing their application using that in containers. Very big customer of ours, very important. They're using some of these concepts here as well.
And they had a talk. They had a talk a couple of days ago.
That's right, yeah. They had a talk yesterday, I think, yeah.
Yeah, so if you want to go back and listen to their talk about how they did that, and they also just published, if you know our Service Fabric team blog, we just published an article there 2 days ago.
We got a case study up there, yeah.
A case study of that.
Yeah, that's a good one, actually. Yeah, I definitely recommend
go check out that case study, go and listen to their talk again on the recording, and they've gone through a similar journey like this in terms of the modernization.
Yeah, that's right. That's right. Okay, so where are we with programming models? Let's switch gears a little bit now. So this is our current Windows stack. This is what you're probably all familiar with, and Mark mentioned a little bit earlier. Mostly .NET full framework. And then on the other side, if you want to use any language of your choice, of course, guest executables, containers. On the Linux side, this is just a preview that we have. It's a little bit fragmented right now. It's a work in progress. Just Java, a little bit of .NET Core, but still only stateless on the reliable services side, but stateful on the actor side, of course. Now, the more interesting question is, where are we going with all this? Here's where we're going. .NET Standard 2.0. This is what we ultimately want, the full cross-platform story with .NET. Everything will be built on .NET Standard, so you can compile your services against .NET Core and then have them cross-compatible between Linux and Windows. And eventually, when we get to clusters that span multiple operating systems, you'll be able to write your services once and run them everywhere. So that's kind of the idea. And eventually, of course, all this stuff will be containerizable as well. Not today, but eventually we'll be able to do reliable services and actors inside of containers.
Yeah, I mean, and this really isn't far away if you think about it.
It's not too far away.
No,
We're
actually getting pretty close. A few months away from getting to that Linux.
Yeah, and .NET Standard 2.0 is just around the corner, so we're getting there pretty fast.
Yeah, so then think about it, you build those apps and run them across all our platforms using one, Service Fabric is the one platform across them.
In the meantime, we have open sourced our programming models, actors, services, and our ASP.NET Core integration. All this is open source, so come check that out on GitHub. We have a home repo, which is just kind of a jumping off point, no code in there, but that'll link you off to all the others, and that's just on Azure/Service Fabric.
Yeah, come
check
contribute,
that out.
Yes,
sure.
We've had a few people add things already, yes.
We have, yeah, it's great. Why not? All right.
All right, yeah, so let's talk a little bit about where we've gone. So that was, most of it we've talked about, so actually everything we've talked about so far is from the developer side. Let me just touch briefly on some of the things we've done inside the management side. There was a little theater talk earlier today done by Chaco Daniel, a guy on our team who touched on some of these things. But I wanted to highlight them here because we hear a lot of people talk about how they manage the underlying cluster itself and the things they have to do. We've added now PowerShell commands that allow you to manage the cluster through ARM. So effectively, I can now create secure clusters and manage those clusters by adding new nodes, upgrading certificates, adding new node types, all through PowerShell commands. So if you go and check this little video out now at this Theater Talk, you can add a single PowerShell command that says, create a cluster, here's the name of the cluster, here is the location for it, self-generate me a cert if you want one, and put that inside Key Vault, make the cluster secure, give me back the cert, and stand up the 5-machine cluster, all with a single PowerShell command, and it makes your life incredibly easy around all of that and how to manage it all. Plus, of course, adding new nodes now can be done safely by simply doing add new node with a Service Fabric PowerShell command, go from 5 machines to 10 machines, or scroll it all back down again. Same with the Azure CLI. This Azure CLI for managing the clusters is not there just yet. It's going to be coming. It'll be coming in the next SDK release. But the Azure CLI there for managing the applications where you directly connect to the cluster itself and be able to deploy the application packages into the cluster is there. So that Azure CLI is there. And by the time we get to the next Azure SDK, you'll have both the CLI and the PowerShell all available for both the application deployment and management, as well as the cluster management and scale out. We had a lot of people ask us as well about creating single node clusters because they said, well, there's this scenario I have where I just want to stand up one machine, and on that one machine, just test it inside Azure and just use it as a dev test side of things. So we made that a super simple option inside Azure, and that allows you to effectively now just create a resource group with a single machine inside it all. It's still hooked up to a Key Vault, but now I can just do deployment to that thing. So basically, it's a cost thing that you can just do just to get to the next level of testing. A great way of being able to do that. And again, you can do that all through PowerShell as well. If you've looked at our blog and how we post things on a very regular basis, we released, and we're just releasing it to GA now this week, a Windows Update patching service. And you can take this service and you can run it inside your cluster. And what it does is it coordinates Windows Update patching across the clusters of machines. So effectively, it doesn't allow you to turn on Windows Update patching on machines, but it talks to Windows Update itself, and then it does the patching of updates across those machines in a coordinated fashion. So if you want to run and have your clusters made secure as updates get pushed to Windows, just take this service, deploy it into your machines, just like we see any of the other services. It'll run and it'll take care of that all for you. And by the way, you can do that on-premise as well as inside Azure. It's a Windows-only feature, I should say, at this point, because of Windows Update. Yes.
Oh, makes sense.
Yes. That's why it's called Windows Update. So not available on Linux yet.
Yes. Linux Update?
Yes, Linux Update, yes. Then we've done a whole bunch of work, and I'll show you a little bit here, just to make sure that we work well with App Insights and OMS. In App Insights, actually, let's flip over to the portal here. Just flip over to my machine here. I just want to show you what we've done here. Inside the portal now here, I've just started creating a new application. And you can now put your App Insights ID here directly into when you create a new cluster. So that means that by default, anything that we write out from cluster events like node up, node down, and things get pushed out to App Insights. And you can go into your application, and if you go and look at our docs, there's this great technology called Event Flow that allows you to basically hook up a number of different ways that you write events, like through iLogger and through Event Source or your choice, and it'll direct those out to a number of different syncs, whether it's App Insights or Elk or some other source, and you can put that into your application and pump all your diagnostics through, and we pre-configure and make sure that all those diagnostics go through to App Insights. So extremely easy now to use App Insights, which is now very scalable for all your events inside your application. If I actually just go and select inside here as well and go to this next node type, you'll see here's that option here for that single node cluster, where I can say, create a single node cluster. A bit of a warning, don't run this in production. One node isn't really good in production. One node's not good in production, I'll say that's right, yeah, don't use that, but it's a dev test purposes. Oh, and by the way, you can't upgrade from this. So if you choose one node for testing, you're stuck with one node. Yes, you can't go. We just made sure that that was the case. Actually, another little thing in here, look, that reverse proxy.
Yeah, that's right, we've added this as well, so it's a lot easier now to enable a reverse proxy if you're creating
Turn that in on your
the
cluster,
portal.
yeah. So, wow, look at that. Just
Why not?
turns it on for you. You just do those simple URL calls between all the services in your backend cluster. And we will have a little checkbox here coming in the next few weeks that will have DNS. So you just click DNS and turn DNS on. Right now, you just have to go into the ARM model. So that's coming soon. You know, we do updates like this fairly regularly. So that's sort of some of the things that we do inside the portal there. What do we got next? Should we switch back to slides?
I think we have something pretty fun.
There's the...
Yes.
We need to switch
Here
back to
you
my
go.
machine
Yeah, back to you again. Okay.
Right. Okay, let's do one more demo. So we love, let me just get this all sorted here a moment, make sure I get the right, where's my cluster gone?
We stand up a lot of clusters in our daily work.
It's here, right,
There it
okay.
is.
So, you know, we love scale, we love perf, we're a distributed systems team, we like that stuff. So we set up 1,000 machine cluster, just because you can, yes. And, you know, we want to show that, you know, these things run at scale, you know, 1,000 machines. You know, we've said it before, you know, we're showing it now. This is a 1,000 machine cluster now running on Service Fabric. These are DV12 machines.
This is a Windows cluster. This is a
This
Windows
is a
server?
Windows
Windows
cluster,
server,
yes.
yeah.
We have this application running on it that was built by our engineering team, and every instance of an application that gets deployed will deploy a number of containers inside all of that. So it'll deploy, every time I deploy an instance of this application, it'll deploy 5,000 containers. So you see at the moment there's a whole bunch of containers running inside this pretty large cluster. And I've got this wonderful little graph that's been drawn on the side here. So if I move this to one side over here, you'll see if I move this out here, I've got this graph effectively now of showing a Windows cluster that's running with 30,000 machine cluster running with 30,000 containers inside it all. And you know, we're hosting this, it's been running for several days. And what we've actually been doing is, if you come down to our booth, is that we've been able to show you and this sort of thing where I can actually do, I'm going to add some more containers to this. So here I go, I'm going to add live on stage 10,000 containers. Oh, all right, okay, I gotta log in first. All right, here we go.
There you go.
Yes, I'm still logged in. Okay, here we go. So 10,000 containers coming up. Here we go.
There it goes.
Here we
Look
go.
at that.
So we're gonna add,
The graph just died here. How many we got? Scroll up, let's see.
yeah, oh, sorry, yeah, the number,
There you go.
here we
It's
go.
going.
Let's just do this here. So it's going, here we go. We're up to 32,000. It refreshes every 5 seconds, 33,000, 35,000.
I'm scared. She won't hold.
Yes. And there we go, we're at 36,000, 38,000, coming up to 38,000. We're coming up to, well, there's 38,317.
Look at
Yes.
that.
And 30, getting up there a bit. You see this graph down the bottom here? And can you
There it
see
goes.
this is 39,000. Let me just, maybe just do this like here. There we go. Now you should be able to see the whole graph down the bottom here as well. And you'll be able to see that we're just close now to 40,000. So there we are. In about a minute or just less, we've started 10,000 containers to this cluster. That's the rate of speed that we can deploy these things. Actually. And just because we can, let's add 10,000 more.
Very secure.
There we go. We're going to add 10,000 more. And you know, we're going to add 10,000 more. We take this thing, we've taken this thing, this is Windows clusters, we take this up to several tens of thousands of containers, and that's the time it takes to spin these things up. 100,000 containers you can run on a 1,000 machine cluster with a DV12 series inside that. Now we're going to publish a number of benchmarks around all of this and just show you how we did all of this on our blog. And as it goes there, it's going to keep, here's the graph. It's keep going with publishing more containers inside there. But pretty much this is demonstrating effectively that we are obsessed with making sure that Service Fabric not only does fast deployment times, but the important thing is fast failover times as well. We're going to show that when you start killing machines inside here, we're going to replace those containers incredibly fast. We detect a machine failure in less than 2 seconds. We start replacing containers in seconds across all of those. And you need to have good algorithms effectively to make decisions about where those things are placed. You're going to make intelligent decisions. You can't just randomly place them all around the place and hope for the best, especially when they're stateful as well. So, there we are. We've gone up to now 50,000 containers. So, this is something that we're pretty sure that, you want to know that we bet. When we talk about it as being a mission-critical application platform, this is the sort of thing that we have to do testing on because we effectively run and bet our own business on this. And we're going to make sure that Windows containers and Service Fabric are the best orchestrator in the world.
Hey, Mark, what about Linux?
Oh, we haven't talked about Linux very much, have we?
Not really.
So, yeah, we haven't, yeah, we could have mostly done Windows stuff here.
We did something cool on Linux.
Well, on Linux, we did actually stand up a 3,500 node cluster on Linux a couple of weeks ago. And on that cluster, we ran and did a similar sort of application. And on that cluster, we placed 1 million containers. This was with an Alpine SKU, so it was a pretty small SKU and things. The cluster was similar size of machines, but we had to get to 1 million just because it was there.
Yeah.
Because we had to get to 1 million. So
Aren't you glad we didn't do the Dr. Evil thing?
Yeah, 1 million. Yes. So yeah, so that's 1 million, and so we're pretty pleased with that. Yeah, but we think we're just getting going and warmed up on this whole thing. Yes, and particularly on our Linux side, we're going to start pushing that. But Windows as well and Linux. We're open to all of this stuff, but yeah, we're pretty excited about this. So this is mostly what we have. Here's some sessions that we'd love you to kind of go to. This was the one that you went to. Here's other Service Fabric sessions that have happened in here. I'd love you to go to the one tomorrow at 9 o'clock, where Taylor Brown is going to talk about the future of Windows containers. Some very exciting developments as you look towards that. And please go back and listen to some of our other theater talks. Swiss Re is a customer of ours who's used Service Fabric, and they're talking a lot about our IoT solution and how they integrate with Event Hub. That happens tomorrow. Of course, please give us some evaluations, and we'll leave you effectively with some resources around all of this. So thank you very much.
Yeah, thanks, everybody.